recording in.
Okay, so let's talk about inverse trig. So this is going to be a little tricky. Let's see how this goes. I'm doing this over 2 days, by the way. I'm doing it on Tuesday also. So we're only going to get to half of these notes. There's 7 pages notes here. I'm only going to do 3.5 pages today. Another 3.5 on Tuesday. Now, one thing you guys should know, guys, quiet please. What is a function? It's basically a relationship. Actually, let me type it up. It'll be easier. That's, yeah, it should be there. Just no, that's so you don't have the right packets. So you need. Do you have that packet? The notes packet. I have extra ones if you need it. All right, let me type this up first. It'll be easier. So what is a function?
Oh, I do have it.
Good, cool. It's a relationship between 2 variables, such that for each input, there is exactly 1 output. And I didn't spell relationship correctly. Here we go. That doesn't sound good. All right. So it's a relation between 2 variables such that for each input, there's exactly 1 output. Let me give you guys some examples.
Thank you very much.
So you guys remember the vertical line test, perhaps?
Yes.
Wait, the one about relationship? Yeah.
So say I have a graph like this, right? So if I drew vertical lines in various places, vertical lines only touch once. They never touch more than once. That's going to be a function. Something that won't be a function, I'll draw another graph off to the side here. Like what if I drew a circle? So that's not a function. Why not?
For 1 output, there's
Or like
2.
a
Right.
Yes.
Yes. For whatever input this is, like say this is like x equals 2, I don't know. But say it's like some x coordinate, right? There are 2 y coordinates that go to it. That's not a function. So for every input, it has to be exactly the 1 output to be a function. So that's a function. That's some of you guys talked about in Algebra 1, talked about in Algebra 2, or talked about it again here. Maybe it's talking about geometry. I don't know if you guys talk about them, but that is what a function is. So vertical line test, vertical lines pass only once. Also, just for every input is 1 output. So like, for example, if I did a table off to the side here. You cool?
Yeah.
All right. Like that's not a function, what I just drew in light blue. And that's because, see how 2 is repeated? The 2 has 2 outputs, it has 10 and 12. That's not good. We can't have that. You cannot have it. So that's not good. Jake, can you finish texting, please?
Mhm.
Yeah, thanks. All right. So anyway, that's a function. Now inverses. You guys probably should remember this. Do you guys remember what inverse is? You switch what? You guys remember? You switch x and y. And isolate y. So let me give you a good example. What if you have y equals 2x plus 1? So we switch x and y, what do you get?
X equals 2, y plus 1.
And if you isolate y, you get this.
X equals 2, y plus 1.
X minus 1 over 2. Now, the other thing that's important to note about inverses, let's do a table. Actually, let me color code it. That'll be better.
What does that say? Switch X and Y.
And isolate.
Oh.
And isolate. So so this is for the original function. That's for the original. What if I were to plug in some points into y equals 2x plus 1? Let's say I were to plug in like 0. What would y be? Into the original function, guys. If I plug 0 in, what do I get for y? 1. How if I plug 1 in? How about -1? Okay. Okay. Now for the inverse in green. This is the inverse. What if I were to plug 1 in for x? What does y equal? Into the green. 0. What if I plug 3 in? What do I get?
1.
What if I plug a -1?
0. 1, -1.
-1.
Oh, yeah.
Notice the columns are switched. See, this is 1, 3, -1, 0, 1, -1. But now it's reversed over here. So that's always true for inverses because x and y switch, right? So that's what's happening for, and that's gonna be a key point for today. The key point for today is that whatever we used to plug into sine and cosine is actually gonna be the output, whereas the output is now going to become the input. So the bottom line, it is confusing. That's where we're gonna spend some time on this. The bottom line, inputs and outputs switch or inverse. Okay, they will switch. Because that kind of sets a tone for these notes today. All right. Now another thing that I'm actually going to somewhat, well, I'll answer these questions, but I'm not going to do the graphics. It's a little confusing. I'll jump to page 2 in just a little bit. Does the sine function have an inverse? The answer is yes. And how would you write it? So y equals sine x. What's the inverse going to be?
Cosine?
X.
Nope.
X equals sin y.
X equals sine y, exactly.
So it's like the same with regular inverse, except we're just adding in sin.
Or you could write it like this.
And once you get a value for x and y, it's like you just plug that in for the.
Exactly. Exactly. Yes. That we did talk about this a little bit when we did the word problems. Like when you had angles, elevation, depression, you had to solve one angles. Like you had like some distance you're from a building and some height you're dealing with. And you had to isolate the angle to solve for the angle elevation, depression. That's what you JP got.
Did we have to use that on the last test?
Yeah, exactly. Yes, we did. But we didn't really get into depth. We didn't get into depth about it. I just kind of just totally just do it and punch. Yeah, we did inverse tangent, exactly. And we're going to do inverse sine, inverse cosine. And today I'm not going to do inverse tan. I'll do inverse sine and cosine today. I'll do inverse tan on Tuesday. But yes, there is one. You switch x and y, or you could isolate it like this. Now, very important. I'll talk about it on the next page. So for sine x, this is the part where if you don't follow, you're going to get lost. For the original, x is an angle. Y is a ratio of two sides of a right triangle. And that ratio, remember, is opposite of hypotenuse. We know this, right? SOHCAHTOA.
That is z.
Two sides, two.
What does that say before? What does that go?
Original. The original equation. Let me rewrite that. Okay, the original equation right here. Y equals sine x. X is an angle. So we put angle like 30 degrees, 45 degrees, or pi over 6, or pi over 2, radians, degrees, whatever. And the output was, what opposite of hypothesis, right? So, right, this is what we expect. However, for the inverse, equation, y is the angle and x yes, exactly. It's a total swap. That will be the ratio of two sides. And that's how you have to think about it. You have to think in reverse in this unit, okay? Or to try this topic. Don't worry about the graph of it. I'm not going to ask you guys a graph inverse sign. But we do have to understand that it is inputs and outputs switched. That's what's happening. And we're going to do some problems just a little bit, how to actually use the unit circle to help you with this. It'll all come together in the next page. Can I clear the screen?
Yeah.
Okay. No? Yes?
1 second.
Sure. Take your time. No rush. Before I move on to the next page, there's one little thing I have to draw your attention to, and then we'll go on to the next page. But again, Anthony, go ahead.
What does it say? No, two sides.
Ratio of two sides of a right triangle. Right here? Of a right triangle. Remember, SOHCAHTOA, right? Opposite of a cone. So that's what it is. And again, this is being recorded, so if you need to watch recordings, you can. All right. Now, one thing I need to draw attention to, and things that you can actually ignore. I don't care about the graph of it. Okay, I don't care about the graph of it, so you can just kind of cross all that out.
For today, at least.
Forever.
Oh, wow.
We'll never have to graph.
Inverse sign. I mean, maybe in college your professor will ask you to. And then you can email me when you're in college, like, Mr. I don't know how to do this. I'll help you out. Okay, but this I want to draw your attention to. Actually, that is a typo. There should be a word not. Okay, so inverse sign is not one of her. Oh, wait. Sorry. I apologize. No, that is correct. What you see there is correct. So what I meant to say was this. This is not this. So that's what I meant to say. Those are not the same. Because of this. When you see this here, that's actually 1 over sine x. When you raise them to -1 power, that's 1 over sine x. Sine to -1x is actually inverse notation. So this right here is inverse notation. This right here is 1 over sine x. Please don't confuse those two.
Y equals 1 over sin x is b over c.
B over c? What do you mean? Where are you going to B over c from?
Oh, you have an arrow pointing.
Oh, because.
Oh, sorry.
Because.
I mean, just find it being circle variables.
I can see that confusion. That should be because. Okay. So again, don't confuse it, please. I'll remind you guys often. Inverse sine is not 1 over sine x. It's not sine the x parentheses -1. When you see the -1 next to a sign, that's indicating that you're swapping the inputs and outputs. If you see sine x parentheses -1, that means it's a reciprocal. So it's two different things. All right. So now let's actually talk about how to find these. Let's do some examples, and then we'll do inverse cosine just a little bit. Okay. So how do you actually do this? Okay. Let me point you guys to the unit circle. I'm going to pull up the unit circle right now, then I'll tell you guys how you actually do it. So for now, you guys just sit back and relax. I'm going to kind of explain to you how you do inverse trig, and then we'll go back to the notes. So for unit circle, let me pull it up. Where do I have it? Right here. Actually, it might be right here. Hold on. Precalculus. Lecture notes. Hold on. You're gonna have this better organized. There we go. Perfect. All right, so here's the deal, and kind of show you the difference between all these things. So again, you guys just gonna sit back and relax. So what if I had like sine of 30 degrees? And remember, x is cosine theta, y sine theta, and y over x is tan theta. Yeah, the answer is 1/2, right? Okay, so we got 1/2. Cool. But what if I did this? Bless you. Or, yeah. I'm not sure it was a cough or sneeze. Okay. Okay, what if I did that instead? In green. Inverse sine of 1/2. What this means. What this means is find the angle for which, guys, quiet please. Find the angle for which sine theta equals 1/2. Or true, yes, exactly. Good, great observation, Charlotte. Or where the y coordinate equals 1/2. Where in the unit circle, guys, let's focus. Where in the unit circle is the y part 1/2? 150 for sure. Also, where else? 30 degrees. So there's multiple places where that could happen. So find the angle for which sine theta equals 1/2, or the y coordinate is 1/2. It definitely would be at 30 degrees, 450 degrees.
So it could be 2.
Oh, okay, it could be.
Actually, it could be infinite answers. Could also be 390. Could also be negative 330. It could also be 510. It could be negative 210. Why there are multiple answers? Because what if I go around the circle once and get back to the same place, right? So there's multiple possibilities. So what happens is that for inverse sine, and again, I'll put this in the notes in just a little bit. For inverse sine, we have a default. We have default range. And it kind of comes from the graph, but I'm not doing the graph with you guys. The default range is from negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. So basically Q1 and Q4. So the right half of the unit circle is going to be default range. So again, like let's say I ask you, find me the inverse sine, let's say 60 degrees. So you have to tell me, sorry, that made no sense. I can't believe I did that. Wow. I meant to say inverse sine of root 3 over 2. Wow, I cannot believe I just did that. That was terrible. Because the input's not the angle. The output's the angle. My bad. The output's the angle. I cannot believe I just did that. All right, it's Friday. So the output is the angle. The input is the y coordinate on the unit circle. So this is probably the most important thing that I'm going to talk about today, right here. The output is the angle. The input is the y coordinate in the unit circle. So my input is root 3 over 2. Where's the y coordinate root 3 over 2 in the unit circle? 2 places, 60, here, and where else? 60. However, we have to have a default range to be a function, right? For every input has to be one output. You don't want multiple outputs. In order to maintain that as a function, we have to have just one output. So I'm going to go with pi over 3 or 60. You can say it either way. I don't care.
Wait, why are you going with that one?
Because that's our default range. Because there are multiple answers it could have. When you go from negative 90 to 90, that covers all the y coordinates. Let's think about this, guys. What's the lowest y coordinate in the unit circle?
0 or 1.
No,
0.
Negative.
Negative 1.
the lowest y coordinate on the unit circle. Okay, so 1. What's the highest y coordinate? in the circle?
1.
1. That's why that's my default range. That encompasses all y coordinates on the unit circle. Okay. Also, here's the other thing too. Sine can't be more than 1, right? Because in essence, what is sine really? It's just opposite of hypotenuse, right? And the opposite's never bigger than the hypotenuse. Never. Right? So here's theta. So sine theta equals opposite of hypotenuse. So what happens when you isolate theta? You get this, right? Physically, that can't happen. The opposite can't be bigger than hypotenuse. So you can do inverse sine of 1, which is 90 degrees, or inverse sine of -1, which is negative 90 degrees. So that's how that works. Okay, now let's go back to the notes. Now I've kind of said my piece about that. Okay, so let's look at this problem. So here's how you do it. Your goal is to find where y equals √2/2 on the unit circle. And remember, our default range,
-1 and 1.
our default range is between -90 to 90. So if you were to look at a unit circle, I'll go back to unit circle right now for you guys. Where do you see y √2/2? 45, perfect. But we're going to go from -90 to 90. Yeah. So the answer is going to be 45 degrees. Of all these options here, it's going to be that one. From -90 to 90. Yeah. From -90 to 90.
Will that always be default range?
Yep, always. And actually even says in brackets up there too. Find it between -π/2 and π/2, which is the same thing as that. Okay. Same thing as that. Now, if you wanted to, by the way, if you really wanted to, guys, quiet, please. You could do this. It doesn't always work. This is just a very special case. So that's opposite. That's hypotenuse. Okay. So here's theta. Here's √2. Here's 2. So this should make sense because that's theta. Remember, that's a ratio, right? Sine is opposite of hypotenuse. √2 is your opposite. 2 is your hypotenuse. So if you did Pythagorean theorem, what would you get for this side here? If you did Pythagorean theorem for, say, calls a, what's a squared plus √2 squared? It's √2. That's good, JP. Yeah, that's right. A squared plus 2 equals 4. A squared equals 2. You don't have to write this down. I'm just kind of more explaining stuff. So that's √2. Now, if that's √2, what kind of triangle is this? If both sides are the same, what kind of triangle is that?
45, 45, 90.
It's 45, 45, 90. Therefore, that's 45 degrees. So that's another way to figure it too, right? That's 45 degrees because of using basic totals. Now, granted, it's gonna be easy as a unit circle because I don't want you drawing triangles all the time. So the unit circle is going to help you tremendously because you're looking for the y coordinate. Let's try this again.
What's the triangle called for 60, 60, 60?
Equilateral, because they're all the same. All right. So y coordinate is √3/2 on the unit circle. Okay, let's look at the unit circle again. Where's the y coordinate √3/2, guys?
120.
120 or 60, but we have a default range. I'm gonna go with Claire. Yes, 60 is correct. I mean, 120 is correct, but we'll go 60.
Will we always want to go to the positive side?
Yes,
Oh,
always. So there we go.
Why is it 5
Or same thing. Yeah, by the way, the way you express so the answers, actually the great observation you just made. For inverse trig, your output is an angle and can be expressed in either degrees or radians. Your choice. I don't care. For inverse trig, your output is an angle and can be expressed in either degrees or radians. Your choice. I don't care. And remember, the input is the coordinates on the unit circle or the ratio of sides. I mean, if you wanted to use a right triangle setup, that's your opposite, right? That's your hypotenuse. So if I were to draw a right triangle here, my opposite is √3. My hypotenuse is 2. If I did Pythagorean theorem again, I know. I just like drawing another one. You can use the one that's in your notes. What would A equal if you did Pythagorean theorem here? Or if you guys remember 36 and 90 ratios. √3 squared plus A squared equals 2 squared. What's A going to equal if you worked it out? 1. Good. 1. Now, in this case, I know it's not obvious, but this follows the 36 and 90 ratio. That's the 36 and 90. On the SAT, they give us in the front of each. Those are the SAT in a couple weeks. They give us in the front. PST, the junior student PST here about here as well. Or junior student SAT as well. It gives us in the front, and it will always be 36 and 90 when it's set up this way. That's 1, 3, and 2. If you actually measure it, you'll come up to 36 and 90. So, but again, let's use unit circle. Okay. Let's try another one. Okay. So you want the y coordinate on the unit circle. What about Jimmy Grappola? We can talk about it. It's not relevant to this stuff, but I'm excited for Sunday. What was that? You can share. What about Jimmy Grappola? He's a good-looking guy. Yeah, he is very good-looking. So, all right, okay. You know, they say like if the Niners played the Patriots in 2019, it would have been like a stare-off between Grappola and Brady because those are both like. We do, and actually, that's a very expensive ticket. Is she really? Ah, in Arizona. Okay, because I'm in Arizona this year. All right. I love to go if the Niners are in it, but we shall see.
I'm gonna see Bills Dolphins is gonna be a good game.
What was that?
Bills Dolphins.
Oh, I can't wait for that one. That should be flexed into like Sunday or Monday night. Yeah. Anyway, okay, enough football. Let's so we got this, guys. We got inverse sine of 1/2, right? Okay, guys, so put your phones away. Stop looking at Jimmy Grappola.
One star Jimmy.
Oh, jeez. Okay.
Whoa.
No comment. We're moving on. This is recorded, by the way. I don't want to get fired, guys. Well, yeah.
I'm really sorry.
Yeah. Okay. It's okay. Sorry. It's okay. Okay. All right. Let's move on. Wow, we that went a whole other direction.
Cut that out.
I'll edit it out. Yes. I didn't say it. There we go. Good. I won't get fired. All right. Okay, remember, we're only looking at the left side, sorry, the right side of the unit circle, okay? We're only looking at this side here. Where is the y coordinate -1/2, guys?
Negative.
Okay. But we must, geez, let me do the text box. 330. We must express our answer between -90 degrees and 90 degrees. Okay. What would be the equivalent angle that's negative and same as 330? So you go this direction.
Oh, 30.
Oh, negative. It'd be
But negative, not 30, negative 30.
Can you not use negative 30 for some other side?
It's fine. It's all on the right side.
Oh, right side.
So final answer, you missed all the excitement. Iris.
Yeah, you missed the out-of-pocket comment.
So it's I'll give you a quick recap. So start is like they're on their phone, and she's Charlotte like Murray Garoppolo and look at the phone giggling like, okay, are you looking at pictures of Jimmy Garoppolo? And I just know she's a good looking guy. Of course, yeah. And then JP mentioned something inappropriate, like he was dating an adult actress. I'll say, okay, there we go, perfect. We'll just that's fair. Okay, and it just
Yeah.
we just spiraled out of control for a little bit. Now to rein it back in. So that's what you missed. And it's all on video. Yeah. Okay. Yeah, I think I will next time. All right. Okay. But it's the last period on Friday, so I don't know how they're going to be. We'll see. Okay. Anyway, so that's the answer. The answer is -30 for that one. So let me go back to the notes.
Why would it be -30?
Because the default range from -90 to 90.
Oh, so it matches with 30, but because it's
Right.
in that negative spot, it's
So
negative.
the answer is going to be -30.
Oh my goodness. Is that
Not
-1/2?
yes,
So if it was 1/2, it would be
not 330 because
Why wouldn't it
default range
be-
for inverse sine. Owen has to stop looking where you guys are looking at.
-30.
Okay. So you have to say -30, not 330. So it's not 45, it's not 60, but it's -30 degrees. So how can you do this quickly?
You do accept the right triangle, so make sure you know yourself the right triangle, make sure you know how sine looks, sine curve. But also, second option might be a little better. Memorize basic values and picture the sine curve, plus minus.
So if you think about the sine curve, looks like this. And clearly y is negative because you have a negative output. So you're looking for the right angle, but really I think the best option actually I don't like any, to be honest with you, I don't like any of these options. Let's cross them off. I'm gonna put option C. The more I think about it, I don't like that. Option C, unit circle. Yeah, let's do an option C. I'm more about options A and B. That didn't make too much sense to me. I was saying these things and I was like, okay, what am I saying? Doesn't make sense. I didn't approach this graphically. I approached this from a unit circle perspective. So use unit circle, find the y coordinate. And remember your default range. Okay, you have a default range. All right, can we move on? And right here, you see this table? What you could do, by the way, this also could be thought of as actually let's go. Let me redo this. Hold on. All right, so let me resize this. Okay, here we go. Perfect. Okay. Let me clear. So let's do these 4 examples, and then we'll do inverse cosine. That should be pretty quick. It's kind of the same methodology. I'm gonna need my plug. Okay, cool. All right. So here's what we're gonna do. So this is input and output
Do we have that?
Yeah. So what you want to do for these examples is swap output and input. Okay, we want to swap it. So in this case, so what's the angle that goes with negative root 2 over 2?
30. No. What is
Look at the table. Look at the table, guys. What angle goes with negative root 2 over 2? Negative pi over 4.
Oh, that's
Right. Let me highlight a few others ones here.
will that be 90 degrees though?
No, it's negative 45 actually.
So I just did 365.
Wow.
Okay, guys, here we go. Inverse sine negative 1.
What angle goes with -1 here? Negative pi over 2.
So we're in the inner circle. Just not throw stuff, guys, please. Thanks. Can you pick it up? Yeah. What angle goes with 1?
Pi over 2.
What angle goes with 0?
0.
0. So all these are the angles, right? These are, now you could have put, if you so desire, you could have put this in degrees, like negative 45 degrees. Or negative 90 degrees. Or 0 degrees. Or 90 degrees. So you could put the angles as well. I'm sorry, the degrees as well. So what you're doing is you're looking for where the y coordinate is the input and the output's the angle that goes with it. So going back to the unit circle again, where's the y coordinate? Let me clear for a moment. Where's the y coordinate 1 in the unit circle?
Right here, right? What angle goes with it? 90 over pi over 2. Or where's the y coordinate -1? Down here. So you have to say it's -9. Or
Negative pi over 2. So let me undo. So that's how I got.
Would negative pi over 2 or negative 90 are they interchangeable?
Totally. Yep. Yep.
So we still give you the circle?
Yep.
Okay.
Yep.
Well,
All right. Inverse cosine. I'm not going to do the graph. Let's cross those off. I'm not going to do this. However, you need to know this. The default range is 0 to 90 degrees. Sorry, 0 to 180. For inverse cosine. Yeah, 0 to 180. I'll explain why in a sec. It goes from 0 to 180. If we go back to the unit circle, let me erase this stuff here. Now, what's the highest x coordinate here, guys, on this circle? What's the lowest x coordinate? So the top half of this circle. For y, but for x, it covers all the x values. So this covers all x coordinates. So when you get your default range for inverse cosine is Q1 and Q2. Q1 and Q2.
You have negative number. No, the angle, I'm saying the reason why that's the default range is because it guarantees all x coordinates on these. No, it's not coordinates. Because inverse cosine. Because actually it's cosine in this circle, y sine.
Because remember SOHCAHTOA, that stuff we did a while ago. Okay. So let's do some examples. And after these examples, then you guys can get a start on homework. And also we can do the check-in as well. All right, so this is the input.
Wait, sorry, but just to recap, so on the unit circle,
Mhm.
we're doing inverse, everything on the left side of the.
It's for inverse sine.
Not use, don't do that because the range from negative 90.
Right.
And then this, what's that?
0 to 180.
0, 180.
Right.
That.
For inverse cosine.
Cosine,
Right.
and then only inverse sine is,
Right.
cosine
Right.
is cosine.
Right. Okay. So this right here, guys, is a table of cosine. So for inverse cosine, swap input and output. Okay, so negative root 3 over 2, I see where. Good. Yes. And 0, I see where 5 over 2. So the answer here is 5 pi over 6 or 150 degrees. And that's going to be pi over 2 or 90 degrees.
We'll always be working with the values, like the same values that we have right there.
Yep. The same thing as the unit circle too. And then lastly, example 10. Let's go to the unit circle. Inverse cosine 1/2. Okay, guys, tell me where is I think I heard it, but where is the x coordinate 1/2? Yeah, x coordinate at pi over 3 or 60 degrees. You have 1/2 right there, right? Okay. Now it's also true at 300 degrees, but we don't do that. It's not part of our default range. So, okay. So, homework. Let me tell you what it will be. It's not going to be all. This is a lot to do. I'm not going to have you guys do 14 because I think it's a little much. But I'm going to have you guys just do number 13. It's just fill out the table. So this is homework right here. It is, yes. Okay.
It's just gonna be that table. And then homework check-in, can you stop
The recording. Just 13, yeah. Yep.